including for observability for the whole company, all the 5 languages we work with. Yeah, and kind of dive into that later, but not any kind of specialization, go more like a fun hobby or projects that can actually take the language forward.
Hello, I'm Constantine. I've been coming to this meetup since it was at Almo many years ago. I mostly do Golang and C, C++.
My name's Eric. Kind of stopped paying attention to when the group died, and now I'm just not paying attention again.
I'm Sam. I'm a salesman by trade, and I've been programming for a while, and I'm building a new company with Go, so that's why I'm here.
Nice. Hi, I'm Kevin McInerney. I work at CACI. It's another defense contractor. We do. We wrote my project in Go about 4 years ago. So I've been working with Go for about 5 years, and mostly full time, and mostly at this company for 4 years.
Hi, I'm Cameron. This is my first time at this meeting, but I've been working with Go for like 6 years now, and I do a lot of stuff with Kubernetes and networking. So Go, a little bit of Rust now, but mainly Go. So I'm just here to kind of check the group out, see how it is.
So we're live since about 1 minute ago.
Last intros you want to go, or do you want to go for straight intros? Or sorry, presentations?
I'm Alex. I'm been a back-end engineer in Go for about 4 years now for a company called Persephone. Before that, I was a front-end engineer with React.
I'm Seth. I started using Go before 1.0. I worked for HashiCorp, soon to be IBM, and then soon to be unemployed. Yeah, I work on the Nomad team because I just absolutely refuse to accept that Kubernetes won.
Who would like to talk first? Oh, sorry, go.
Yeah, my name's Jake. Been working with Go for about 3 years, and with Kubernetes, Envoy, and networking.
And volunteer, you want to go? Sure.
I don't have a PowerPoint. Don't you want me to go first?
I'm not good. Either you want to signal as your tagging to on this laptop, or you can use the AirPlay.
I can do
You can use the AirPlay directly. Turn on the members first.
Maybe I go second.
Yeah. We've got HDMI coming, so
I think it's better to do now.
yeah.
I got the two tops, so definitely gonna like you do both in a row.
Yeah, that's fine.
Probably the funner one, I guess. You guys hear me okay here? Like, do you need particular position?
I'm not sure. I'm guessing that's the mic there.
Oh.
I assume.
Okay.
Or is it that one that's dangling down in front?
Okay, I'm
That's
moving.
probably it. Yeah.
Hello. So, like a lot of folks during the pandemic, I got really bored and started doing terrible things to my house. So this is a story about all the terrible things and how mostly you used Go for it. So first off, I wanted to build a remote control for, see if a package got delivered, see whether everything is parked in the driveway, which kids are home. I got 3 kids, and 2 of them are in their 20s and drive. So keeping track of who's home, who's just the car, do I have a car available, or did all my kids steal my cars? It's always a pending question. We've got a gate because we're on a busy street, and we garage door and a board. So the goal is I'm going to put everything into one Go file, make it super simple, and then convince my family that it's actually a phone app by dragging a link on their phone desktops, and they think it's actually an app, but it's just a website. So that was the whole plan. So the common approach to this problem would be using something like Home Assistant and do all the plugins. But have you ever looked at that code? It is disgusting. I would never know. No, that's. I just want one little Go file. That's it. I don't want this giant pile of crap. So I looked into some of the commercial home automation stuff. That's all very Roach Motel. You can buy into it, but you can never get out of it basically. There's a few that are borderline open, but even then you're just kind of waiting for the next shoe to drop in the commercial world. So last option of course is to get up and actually look out the window, but too lazy for that. The whole point of this is not to have to lift my butt out of my seat and to be able to look at everything on my phone or whatever. So starting off with video feeds. So I've got 5 different types of vendors of IP cameras all over the place because I've been building them over time, and I do a lot of hardware testing, so I also end up with leftover junk. And I buy a lot of test options, someone goes out of business, I buy all their stuff, fill it in my garage, my wife hates me. I dig through it all, and then I donate 3/4 of it, put the rest in our lab, and repeat that process. So I end up with all kinds of random crap everywhere. I take the good stuff and use it for the house, and the rest of it I either donate or put in the lab in the rack. But the problem with IP cameras is every camera has its different like firmware configuration, different URL, different authentication. Some are MJPEG, some are like RTSP. So trying to get like a common ground for pulling video feeds is really annoying. So I found this thing called Motion, which is pretty cool. It's like motion detection, but it's the tool is just called Motion or Motion 2 on Linux if you want to install it. And it already handles all the fun configuration of like RTSP versus MJPEG versus this camera and that camera. You just create config files and and it just goes and grabs all the video feeds, puts them all in the same place, and then does motion detection. But it also has this other cool feature, and that provides a kind of unified endpoint to reserve the image feeds back out again. So if you browse to the Motion 2 web server, it gives you like image feed for camera 1, 2, 3, 4, 5. They're all in the same format. It's all beautiful. So you install one little package called Motion, and then you have like a magical combiner of all your different video feeds into one web server you can then pull them back from. So I don't really care about motion, but I definitely cared about having a single endpoint to go grab all the image feeds from as opposed to having to build my own scraper for every type of camera. So I started working through that, and then it got it to work. I hooked it up to Slack, and anyone walked in the driveway, I sent a little picture, posted to my own personal Slack. Like, it's fun to create your own personal Slack server, because you can create your own stupid accounts and notifications, and it auto deletes after 10,000 messages. So I just spam video continuously to my personal server all the time, and it's great. It's like a video buffer that Slack pays for. And since I paid them so much money for my day job, they might as well pay for my side job. So yeah, so this worked pretty well. Got a thermal camera. This little bottom box is the next thing we're talking about, though, which is at the time I was doing a lot of consulting work where people were delivering like huge, expensive hardware to my house, and people kept trying to steal it. And I lost like $20,000 in networking gear one day that someone stole my like front area, and I was like, this sucks. So I kind of went overkill. I was like, I need a Dropbox, but I need a big Dropbox. I need a Dropbox so big you can put like a 2U server inside of a packing crate through it. And it has to be like, take your arm off level of security and try to take something back out again. So I tried looking at those like big donation bins, the ones you all see people getting stuck in when they try to steal clothes. And those weren't big enough either, because the box, you can't actually bend it enough to get it through the thing. So it being pandemic and me being stupid, I decided to go start from scratch, and I bought a 6-foot by 6-foot dumpster, brand new. I found a welding crew, and they welded the whole top of it off and flipped it upside down again to expand it. They built a custom door in the whole thing. They had to drag it with a pickup truck across the lawn, knock everything down, pour concrete pads, like all this stuff. And the whole thing actually has a custom door kind of welded up the back of it, Ethernet connection and power. So this is actually a pretty good condo. Like if you're looking for a place to live in Austin, it's actually not bad as far as like real estate versus. So here's what it looks like from the front side. Like looks fairly pretty. You've got a little thing, you can open it up. Most people don't realize the drawer is like 50 pounds. So you see these like, especially the folks who are a little bit small, on the smaller end, trying to open up the doors for package delivery, and they're like pulling their whole body weight down, trying to get this giant steel contraption door open. And if you let it snap closed, it'll probably break your arm off. But here's what the backside looks like. It's a full-on dumpster. So your question?
Did you have to get like a set of permissions? To,
what?
Did you get
Since we're streaming, it's probably not a great time to answer that question. I did find out that when the city gives you grief about your wall being too high, it's not really that your wall is too high, it's that your ground is too low. So if you're able to make your ground higher, it doesn't matter how tall your wall is. So there was at one point in time when we were building out a new wall because the wooden piece of crap fell apart. And they said, your wall's too high. And I said, no, come back tomorrow. And they said, no, it's not. I'm like, yep. And they said, your wall's just as high as before. I'm like, yep. But your ground is 2 feet higher. So keep that in mind. You can always raise the ground if you don't want to cut down your wall. So yeah, it's a full-on dumpster. And you can see it's all welded back there. It's got the things. There's a power line running through that. It's got a bunch of conduit underground that goes to the Ring doorbell, PoE, all kinds of fun stuff. So it's got a couple cameras in it. One looks down at the package floor. One looks at the door when you open it. So you get like the face picture of whoever dropped it off. And you also get the camera on the bottom. And you can run it through like YOLO or whatever and start recognizing like Amazon versus UPS versus FedEx logos on the packages and say, you got a FedEx package or UPS package. These big plastic things are apparently, like, they look like pieces of crap, but that's $100. And they're expensive because they're actually the pads you put on ballet slippers for doing ballet classes because they're Teflon pads and they're non-stick. So packages come in, they hit that Teflon thing, and they just shoot off right at the bottom. It's great. And the entire bottom of the dumpster started to rust out after a while, so I got this giant 50-gallon bucket of silicone and just like dumped the whole thing into the bottom. And it left this like 3-inch like loopy pit in the bottom and eventually cured. Now it's all bouncy. It's great. With all this stuff, like I've got the dumpster, I've got the gates, I've got the garage, like I want to figure out like how to wire it all up. So I did the normal human thing and dug giant holes everywhere and ran cables everywhere because apparently I didn't know about wireless. And so hooked it up to a little electromechanic relay on the Pi's, little single channel relay. The cool thing about electromechanical ones is you use like a 3.3 volt, like right off the Raspberry Pi itself to trigger it, open and close, but you can put whatever current you want through the connection. So you can put a mains voltage, whatever you want through it. It's not electrically connected to the switch itself. And it makes cool little clicking noises too. So every time you do it, it goes click, 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 click. It's great. So first approach, did lots of holes, run lots of wires. Then I found out that for the gate control, I found this is where the RF control comes in when you like hit the keypad or you little control. It just comes into a circuit board inside the gate controller itself. And so I just jammed 2 wires into that, ran that cable all the way back to the server room, hooked that up to the Raspberry Pi. I'm like, all right, I got this. All I'm gonna do is like forcibly short this circuit and it opens and closes the gate. And I don't know anything about electronics, but that seemed to work. So here's a little keypad. Here's where it comes into the thing. There's jammed some random wires in there. Hooked up to this guy, ran a long cable all the way back down the line again, and eventually back into the server room. The problem though is like a thunderstorm came by and like somehow inducted current into the ground and fried everything. So I lost like 10 grand a year in the server room because everything fried, mostly because of that stupid cable in the ground that you just saw. So the voltage went through the cable all the way into the server room, fried the Pi, fried everything else around it, fried the relay, all the switches were dead, it was just chaos. I was like, all right, let me go do it the smarter way, which is not run a giant cable and just instead take the existing remote control for your garage gate, whatever your little key dealie is, rip the battery out of it. The battery in this case is already a 3.3 volt battery with the exact same voltage as the Pi has. So let's hook up the Raspberry Pi 3.3 pin to the positive and the ground to the negative and so on. Hook up the little button presser thing on the clicky thing to the GPIOs and the Pi itself, and then connect that to the relay. So you're effectively pushing the little remote control button through the Pi's GPIO, and that worked way better and it didn't break. So it's all one big like Go file. It has built-in Let's Encrypt for TLS. It's just ported through the firewall, and you can look at the images from the Motion 2 server that are buffered in memory in Go and then served back out in web request to the user. So it looks like this, and I think you can do a little live demo if you want to stalk my family. So yeah, you can let's freak them out, open the gate. So that little click thing, and now you can slowly watch the gate probably open up here. So there we go, all right. So now the family's like, what the hell's going on? Who's coming into our house? Anyways, he closes it again. So you can scroll down a little bit, check on the pool. Here you can see the drop box in the middle of that dumpster. You can see many packages are dropped down the bottom there. And see the little timestamp. Here's a bunch of conduit coming in. This is a big rubber pad that I poured on the bottom of it. And then there's some other feeds here from my other cameras going up and down the road and stuff like that. But yeah, it all works. So thanks. Any questions on that?
Does Motion use FFmpeg under the hood?
It's all built in. It's all nasty C that randomly crashes.
Oh, nice. Interesting. Because I've been doing a lot of video stuff, and I can see doing this with FFmpeg pretty easily. For the video part.
I have a question about the cameras. I was reading reviews, and I think a lot of the cameras, even if they allow IP access, they still require internet connection when they reboot. So basically, if they reboot without having internet, then they're not going to stream anything. Even if with the internet, they will continue streaming locally. So did you figure that out? Or?
Yeah, these ones okay. These ones don't do any internet. They're not like the cloud controlled ones at all.
No, but I'm saying if they reboot without the internet, then they're not going to work at all.
Yeah, they don't need internet.
Even for initialization?
Yeah, don't need internet.
Which ones did you get?
There's TP-Link, Armstrong. 1 second. I can actually find it real quick. So I'm going to cheat and show you the product real quick. So here's what I work on all day. But the nice thing is it also has an inventory of all the cameras, so I can actually answer 2 questions at once. It's like 2 of they, but it's 1 of
And the U.S. government has a website of cameras that are not built by state-sponsored surveillance organizations, so that can be handy too. We had to actually buy
At
some
least
cameras
only improved ones.
Yeah. No, if it's our state, then sure they can surveil all they want, but not the other countries.
Yeah.
This should be, so look, there's one M-Crest IP8M. Let's see.
I have one of the Amcrest cameras, and they don't work for local recording if they don't have internet when they reboot.
Oh, there's no local recording.
Yeah, but they don't work. I think I haven't tested if they do the thing, but basically they get their configuration from the internet, even the local one.
This one I know it doesn't because there's no outbound access on the network.
Okay.
It's there's no routing outbound. This is scanned from inside. So the other ones
You
are.
make sure that they don't have access to internet at all, right?
I mean, they have access to the video network they're on, but that's it. They're just locked off in a little video LAN basically. The other ones are the TrendNet TV IP 310PIs. And there's some Nest and some other crappy ones there, but those are kind of useless for one thing. Any other questions about site? Thank you.
Really cool.
We have HDMI, so
My internet is not connected.
yeah, it's right there.
I'm not a member, so I can give you their password without any guilt. So if you go to Capital Factory members, the password is center of gravity, all lowercase.
That will change soon.
What is it?
Sorry. Center of gravity, all lowercase.
Hey, if they didn't want it to be so easy to guess, they should have made it that.
Not even numbers.
I mean, yeah, at least put an uppercase letter in there.
And you have to use the number of hours.
I'll get over here. Where do I plug in?
Yeah, it's right there on the wall.
I'm practicing this line, so we'll rest here, it'll be fine.
We're not a super critical audience, so.
This should be casual.
Let me stop sharing here because it's going to steal.
I think maybe you have to press like one of the buttons or something.
Yeah, that probably shape on.
Oh, yeah, that's a good one to press. There we go.
Okay. I don't want to. Where is the mirror? This is my work laptop, so hold on. None of that is pulled up. I don't. It's because of my other external monitors at home. I guess.
What are you trying to do?
I just want to get my PowerPoint up there without showing all of my other stuff.
It's probably like a setting in my PowerPoint. Like, how do you do that stuff?
Sorry for stopping that. Forget it, give me the password.
I think you have to disable mirroring.
I just did. Maybe someone.
I think you enabled it.
Display options. Built-in display over. Okay, I don't actually know how to get my PowerPoint up there. Can I just like send it to someone?
Sure, yeah, go for it. You have to holler a little bit, switch wide over here.
Yeah, sure.
I'll go in the meantime. I'm not had that. Okay. Hi, I'm Sam. Samantha, but I go by Sam, yeah. So I didn't prepare a PowerPoint just because I figured I'd be a little more informal this first one. And also I didn't know what to expect, so yeah, hi. There's a lot more of y'all, which is exciting. So I said that I would speak about a book, and it's a book that I wrote. And it's called Go Programming from Beginner to Professional. And it's learn everything you need to build modern software using Go. So basically, I wanted to talk with y'all about, oh, and I want my phone so I have my notes and my talking voice, so I make sure I don't ramble for everyone. But basically, it's kind of like, people probably don't know, like, if you're interested in writing a textbook, how do I do that? Who do I get in contact with? How did I even get into it? How do you decide on content and so forth? So I figured I'd kind of touch on some of that. I thought it'd be pretty interesting. And if anyone's interested in the future on writing textbooks or reviewing textbooks, let me know. And I can help put you in contact with the right people. So yeah, my first question to guide me on talking about this is like, why did I write this? And how did I even find out about like writing a textbook? And so I presented at GopherCon main stage like 2 or 3 years ago on integration testing in Go. And all of the fun that comes along with that, from like retries and not putting sleeps everywhere and using the assert package and so forth. And so it was a hit and I had a lot of fun, and I presented at GopherCon a few other times, and the packet publisher people just reached out to me because they saw that I was a speaker at GopherCon, and so the lady reached out. And we kind of developed like a relationship where they'd like reach out to me and ask if I was interested, and they still do. So once you get into their network, you're in for life, and they will always ask you to do more and more. And so that's kind of how I got involved with them. And they had, initially this book was supposed to be for 2 other people, and one person backed out because it's a lot of work. It's a lot of time, and so then I filled that person's role, who happened to also be called Sam, and so it was really funny. So I filled in for Sam, and then the other person backed out, so then it was just me. And so that's kind of like the whole process, because I didn't know what all was involved, and I didn't know how much time it would take and everything, so I figured if I was doing it with someone else, then it would be a lot easier. And you'll probably see that, and you don't think about it, but if you look at most technical textbooks, it's usually co-authored, if not like a bunch of authors, because it is so much work. And we all have jobs and lives, and we want to sleep too, so you have to sacrifice. And I was living at home with my dad at the time, and I didn't go out, so I had time for a textbook. So that's kind of like why and like how I had the time for it. What is my next question? I just scrolled. So for my textbook in particular, I've been asked a lot like, who is the intended audience, and do I have to know anything about Go to read this? And the answer is no. This book is definitely designed for people who are new to Go, who don't know much about it or the community. And I intended it that way because I really like giving back to the communities that I'm involved with. And you'll see me a lot volunteering at Texas State University and doing other meetups. And I help out with GopherCon, reviewing the call for papers, and GopherCon EU. So I really like giving back to my community, and writing a textbook happened to be the next chapter in my journey. So it's totally for beginners or people who are transitioning to Go from another language. And it definitely covers like all of the basics, from how do I define a variable, like what are the different data types that I can work with in Go. There's 21 chapters, so I'm definitely not going to be like, okay, chapter 2 was this. But basically it's like, yeah, variables. Once you have your data, like how does it flow through the program, like what can you do with it? So kind of like command and control. We talk about core types, complex types. This book also had a lot with respect to like, I guess when it comes to writing any book in general, it's like, how do you keep it current? And we know Go is like always changing. For example, 1.18 had a lot, or Go version 1.18 had a lot of updates with respect to adding generics. The concurrency package had updates for safe access for the sync.map. I think there was sync condition that was also added. So there were like a bunch of updates specifically for 1.18 that I was like, okay, how can I account for these and make sure that this is like future-proof, if you will, and relevant for as long as possible. So definitely things like that are like part of an authorship like mindset. Yeah, so then it goes through like, how do you handle errors in Go and not panic everywhere, because I know some people might want to do that if you're like new to the language. And then going into packages and modules and common things that you might work with in Go, such as the time package, or working with like file system operations and different database packages that you can work with. So in the book in particular, I touch on the PQ package, which I do touch on. Like, there's plenty of other packages, and I actually don't even think that one's like super actively maintained. So like, right, future editions of this book would be like updating, say, packages to maybe using PGX instead, because that's actually what I'm using right now. So like in my current role at Diagrid, one of the main things that I'm focusing on is our managed services for working with things like the Dapper APIs, enabling you to build these like scalable, modern web applications in a cloud native way. And so I'm working a lot with Kafka and Postgres, and so like, you know, the next iteration of this book can bring in some of those learnings, or I can use it for another book. But you'll definitely see like more talks here probably on those topics, because that's like what's current for me. So stuff like that's in the book as well. And also, I know in like the CLI world, so like the book also touches on CLI. So like hopefully at this point you're gathering it's very comprehensive, not only in like the content from chapter 1 to chapter 21. So it's about 650 pages, but also each chapter is like pretty in depth. And I've definitely tried to put like my special spin in terms of, you know, tips and tricks that I've picked up along the way. So yeah, I don't know. There's a lot in here, and if you're interested, I can get with my publisher about getting a book, and we can maybe do a raffle or something for one of the upcoming meetings. That could be fun. And I can even sign it. I gave one to my boyfriend's dad because it was really cute. He's like, I want to read one, or read it. But I forgot to sign it, so I still need to sign at least a copy. Like, that'd be pretty cool. Okay. Okay, I touched on some of the content. Again, it's like a lot. I cover a lot of ground, so I guess I'll touch on some of the like highlights in the end. I will say were some of my favorites because it goes a bit beyond the basics, right? So it's like taking someone from a beginner level to a professional level, and what does that mean? And so part of that is going through in the beginning and adding in, you know, the special tips and tricks, and adding in things that not everyone loves to talk about, maybe like testing and tips and tricks there. And in the end, I think one of my favorite chapters is on like monitoring and how do you containerize your application, what does a Docker file look like, right? So cover a lot of ground, and there's things like OpenTelemetry and Prometheus, like defining counters on your web application and seeing what that looks like. So let me see what else I wanted to touch on. Okay. And I touched on keeping it current, because I've actually been asked a lot on like, how do you keep a textbook current? So I don't know. I think it's like everyone has to keep things up to date. I think it was in, I think it was like the Go blog or the go.dev. Even they have to keep their documents up to date and current with things like the empty interface becoming any, like the any alias. And so like I touched on that in my book too, but I think if you go to the go.dev blog, that's not referred to. Like it's like everyone has to keep things up to date, so we try our best, right? I think that's pretty much all I had. Oh, okay, actually, what was the writing process like? So it's kind of awkward too. Like, we're used to working in an IDE or a terminal, and so writing code for a textbook is kind of different in the sense that you have to write it and you keep it in a repo, right? Like you would normally expect. And part of the fun is like finding these fun examples that are still relevant and like real world and beneficial to the reader. But then part of the fun is copy pasting that over to Google Docs. So yeah, it's like the writing process is basically like you start with the outline, high level chapters, what is the content, who is the book for, and then you have that and you have the subtopics for each chapter, and you think about ahead of time what are the different coding exercises that I want in each chapter. And then from there, you work on a Google Docs and you fill in the content, you put your thoughts down, then you copy paste over the code and hope that you get all of the syntax spaced over nicely, because it's not just as easy as copy paste. Like, you have to go back and check it over. And then I had 2 technical reviewers for my textbook. Oh, you have a question? Go for it.
Yeah, well, why did you use Google Docs? Like
Don't ask me.
the Go programming language, like Carnegie Richard, I think he basically wrote it like in raw. So
Yeah, so I was kind of forced into what my publisher used, and this is me kind of explaining their process for writing a textbook, and it includes Google Docs, and then it goes into a PDF. So that's, yeah.
Well, from RAW, you can also generate PDF, right?
I just did what I was told.
Yeah, they have editors and they won't do it their way. It's almost impossible to just do your own everything.
Yes.
Publisher.
Yes, unless you go through, say, and publish your own book and put it on Amazon yourself. But if you're working with someone like Packet or O'Reilly or whoever, they'll have their process, and this is the Packet process. So, yeah, you put the content down, the code down, and then you have reviewers, and I had the 2 reviewers go through and they read each chapter and look through the code and give me thoughts like, hey, for the middleware section, there's this Alice package, it might be nice to touch on that. Stuff like that, it's really nice because everyone's got their own different perspectives and different tips and tricks, and sometimes you'll get feedback of, hey, this could be made clearer if you put it this way instead, or even reorder something. So it's kind of, you get varying thoughts on the technical reviewer feedback. And the whole time you're writing the book too, you have, I don't even know what his role is, but I had an editor and he would always look at my grammar and syntax and stuff like that and fix it. Because also, coding, like the code part is in a P style and the header is in X style. You know, there's like all these styles that you have to abide by in order to get it to the next phase, which is the PDF. And at that point, you're like nearing the end, which is nice because it is a lot of work. And 21 chapters, my goodness, this I worked on for a year and 3 or 4 months, I would say. So it was a long journey and a lot of effort and late nights, and yeah, so once you get it to a PDF, you do a final pass over and hope you catch everything that was like left over, or update images if you need, and then it goes to be printed. So that's pretty much like the writing process and what that looks like for working with a publisher. I think one of the other really cool aspects is you can dedicate the book to someone. So I dedicated it to my mom, and yeah, you can put things to people and stuff like that. So it's really special too on that front. I think that is all, yeah. And then the part that they don't tell you about is marketing your book. So,
Speaking of,
yeah, you want my textbook.
can you post links on the meetup page
Yeah.
and on the ATX Slack?
Yes, I can.
Thank you.
It's on Amazon, and I have a lot of really good reviews so far, actually. So if you read it, give me a review, and I can ask them about discount codes or getting a book for the raffle or something in an upcoming meeting.
Yeah, sure.
So yeah, stay tuned.
And then,
Yeah.
Sam and I are pretty involved with GopherCon. We had Russ Cox personally give us some of the 10-year anniversary pins. Nice. So I brought a bag.
Awesome. Thank you.
So yeah.
Thank you. except to me. Oh my gosh. DoorDash asked me to review the fact that they brought the HDMI cables. Okay, like they did a good job. And then they're like, what did you think of the taste? What?
You know Steve Brazos?
Yeah, that's right. I guess it didn't taste very good. It was metallic, but it worked really well for putting things on the screen.
That's great. I don't know if I have them.
What are the odds?
Yeah, my friend from Spain, he shared the book and LinkedIn.
Wait, was it Manu?
Mo,
Yeah.
So we used to work together in California.
Holy moly.
Yeah.
Wait, so Manu is with the test containers.
Yeah.
He's a maintainer on test containers, a big open source project. I don't know if they're in CNC yet, but
They got acquired by Docker.
yes, yeah. I contributed to them and I presented, one of my presentations at GopherCon was about test containers, so they like all know me. And we're gonna meet at GopherCon. So if y'all are going to GopherCon, I'll see y'all there too. Cool, I've not gotten to do this quite yet, so this is fun. Like, how do I sign it?
I've heard that if you ever see your book in like a public bookstore, you're allowed to just open it up and sign it. Like, yeah. Like they cannot stop you. Like I was told by Barnes & Nobles that if you see a book you like published or contributed to in the shelf at Barnes & Nobles, you can open it up and sign it. All of them. And they'll put a sticker on it saying author signed afterwards. They actually want you to. It's great.
Okay.
It's really cool to really elaborate prank.
I worked on the Nessus book probably like 15 years ago, and they're like, "Hey, I go sign it." I'm like, "Okay, I want to sign it." I guess.
All right.
Is anyone in the next, or are we able to talk, or anyone else wants to go?
Me?
Yeah, that's not sorry. Cassie, sorry.
I sent you just like the proper paper
On Slack.
repo on Slack.
Okay, sure.
So
Yeah,
we
we pull
can
that.
share, and I'll figure out for next time, I'll like come earlier today or something, so I can screen share all of my things.
Yeah, that's fair.
In return, I'll screenshot all of my work.
I might open source anyways. So I guess it doesn't matter.
That's fair.
And this will be a sneak peek into, I presented on the standardizing errors, like errors package I wrote. That's open source. I presented it at the Open Source Summit, and I'm going to give a lightning talk on it at GopherCon. So if y'all are going to GopherCon, this is a sneak peek. It will have very similar content, but it will be slightly different. That's just my repo, so we can just easily scroll along. So yes.
Use this and scroll. Just trying to backdoor my stuff. Yeah, this one is instructive. Feel free to scroll it.
Okay.
Sorry, it's on this like next page.
I know. Oh wait. Oh,
Does that work?
that's fine. No, I'll just do this. Okay. So yes, standardizing errors, a practical guide with Dapper. We kind of talked about what Dapper is, and I wrote a package to standardize errors that is open source, so y'all can hopefully use the package and then like standardize and enrich your error messages. So let's look at that. So I'll give you a very brief high level like intro to Dapper. We'll talk about like why we should standardize our errors. The richer error model I'll touch on because that was the inspo for the package. We'll go into the package itself, which is in the Dapper Kit repository. Again, 100% like open source, all go. And then like I'll mention where we're at. We are standardizing, and in the effort of standardizing all our APIs, or like the errors for all of our APIs in Dapper, and there's a whole bunch. So it's a very slow process. That's me and the team. Let's get into it. So, okay. Dapper, this is the nice snippet that everyone gets for Dapper. Dapper stands for Distributed Application Runtime. It's a portable, event-driven runtime for building distributed apps across the cloud and edge. And as you can see with the blue like gradient to black, it's that set of APIs for building secure and reliable microservices in a cloud-native environment. Once my scheduler PR is in, there will be another square for my scheduler for people to use that to schedule jobs. Not yet there.
And yeah, Dapper is the number 10 CNCF project. People say it's the backbone of their services. It does not have a lot of expense, but there's a ton of payback. However, 53% of our users say that it is hard to debug and troubleshoot. I feel like this is kind of like a general thing with distributed systems, and this is why it's important to standardize errors in general, and like for us specifically as well. So let's just talk about high level why it's important to standardize our errors. And I'll show all the Go code for the errors package here in a second, just building up to that. Right, we want to give our users a consistent and reliable error that is enriched, giving them a smoother debugging process, giving them clarity about what app ID or what resource the error is occurring with. And then the same way that it is standardizing errors for users, we are also writing the error in a very standardized way, so that's kind of encouraging more community collaboration, because it's a very similar process of writing the code. And all of this leans towards being very empathetic to our users, right? We want to help them. Okay, so we use the richer error model for inspiration. So here is a snippet from the Google richer error model. You can see the message status containing the error code, error message, and details. And then, if y'all aren't familiar, these are all the possible error detail types there are. So for us in Dapper, we required the error info, error detail type. And so let's look at that one. So obviously they have their own specific attributes per error detail type. So the error info, error detail type has domain, reason, and metadata. So for us, we put dapper.io, and then you fill in the reason and metadata appropriately. And we'll just glance at a before and after with some GRP curls here in a sec. Before I get into the GRP curl, I'll just give y'all a high level overview of what this is. So we have on the left a Dapper enabled cart application publishing data to our message broker. Maybe we're using Redis at the top there. And then on the right, we have this shipping Dapper enabled app where that data is being routed back to the app. So already there's a lot going on here. It's pretty simplified. That's a high level explanation, but there's plenty of areas for errors to occur. And so if you were to run a GRP curl against our publish event endpoint with a fake Kafka name and a fake topic, we used to get this. This is pretty standardized, right? You have your error code and your error message. Now with Dapper, I've enriched this API, the PubSub API. You get this exact output. Now we have error info type and resource info type with the appropriate attributes filled in. And so that can even be further expanded upon to include, say, a help link. So maybe you're how does this matter to me, Cassie? You can actually use the errors package that I'm showing you the output from me using to include help links to your users so they can more easily copy paste and enable themselves to maybe figure out the issue that they're looking at. Again, here's all the possible error detail types we just looked at, error info, retry, and help. So the meat of it, the errors package is in the Dapper Kit repository. So Dapper Kit is a utils repository. It's kind of a catch-all. If we need something in more than one repo, it kind of lives there. It's all Go, all open source, so feel free to use the errors package. It does use the builder pattern. We were already kind of implicitly using that, and then we just doubled down and changed a few names and made it explicitly the builder pattern, constructing our object kind of step by step, making the error mutable by the caller. For us, very large open source project, we could not break our users, so we could not change And like this is a thing upon PR review, we have to make sure we don't change anything that users are expecting when we're like standardizing the errors. We just like enrich it. And it is based off an official proposal. Dapper has this whole process where we have a proposal repo and you have to kind of submit a general proposal there. Now let's look at the fun code for it. So the consumption of the errors package looks like this. We have errors.newBuilder. We take in the HTTP and gRPC codes, message, and tag. Then we enrich the error with the error info, error detail type, giving it, this is the reason, and then the metadata, and then you just build the error. So that's our builder pattern. It's very simple. Now let's look at what those functions look like. Starting with our struct, so we have the error struct that has, the error details, the error codes, message, and tag. Then that is inside of our error builder struct. And then the actual function implementations are as such. We take in the error codes, the message, and tag, and we return our new builder here, filling in the appropriate attributes. Then we enriched that error with the error info type, right? This is off our error builder. And then we append our error details, and then we return our error builder. And then you simply call build, right? For us, we have a little check to check that we have our required error info, error detail type, and then we return the builder.error. So we implemented the error interface such that we did not have to maintain an additional type. We just return error. So that's a very nice thing because our project is just so large already. We do not want to maintain like a specific type for us, so implementing the error interface was very important. So that is why this return type is just error. And then kind of where we're at, I did the pub/sub API, my coworker Elena did the state API, so those are standardized and a lot of work is still in progress. I opened issues for like all the other APIs. And we have users contributing to that, so it's really great. It's like a good first issue, like Go, open source, very large CNCF project. So a lot of traction there. So if that excites you, feel free to build the feature with us. And yeah, that is my presentation. Thank you.
I had a question actually. How do you handle error wrapping with Dapper Kit?
So we do the wrapping of errors. We haven't done that a whole lot with like our new errors package, but it does work with like error wrapping. We've done 2 of the APIs and we haven't wrapped the errors. It's more of the like high level API errors. So we haven't had the error wrapping piece really.
Alright, so one more talk that's a little different, and I've got, compared to the previous one, there's more code involved for sure. So I'm going to clear some stuff real quick. Let's make sure I actually code it. How cool is that?
That's pretty good.
Almost routine. Alright. Well, if you squint really hard, it might be. So I was working on a project the other day. So we have a customer we have a project where effectively we get data from a provider who is XML API, and they give us a bunch of CSV files effectively. And so let's find an example. So we get these things that are basically big database dumps. It's basically a CSV file with GZIP compressed. They're pretty big. They're like 4 to 10 gigabytes, depending which one we get. If we dump one of them real quick and just look at the output to get a sense of what data we're talking about is.
Missed the slash.
Thank you. There you go. So lots and lots of blobs where the first value is basically a domain name. or a host name, then there's a comma, a Unix timestamp, and then an IP address. So effectively, it's like a cached DNS data set. It's like a host name and then a timestamp, IP addresses, one or more IP addresses. The idea is we want to take this giant list of all these possible host names and IPs and turn it into, kind of flip it around the other way and say, for a given IP, tell me all the domain names, and for a domain name, give me all the IPs. We're going to roll all these up because there will actually be duplicates across the data set. So there's multiple CSV files, roll them all together for the same host name, you may end up getting like multiple files, all the same value, the same key. So there's a roll-up stage involved. And because these things are gigantic, the idea is like, how do you serve this data really quickly? And it's also being updated every single day. So we're chewing through 10-something gigs of raw files, spitting out about 50 gigs of compressed files in the particular level DB format we'll be talking about, and then using that to serve requests to customers who then want to resolve which domains are available. The whole point behind this, though, is that if you're a customer of ours and you say, I want to scan all of my host names and my domain name is run0.com, I'll pop in run0.com in my target space, and we'll automatically expand all the possible host names ever found in your domain and scan them all. So we try to make the whole magical find all your stuff thing happen. And we do that through licensing data sets like this. So going to more of the code side of the presentation, this is really titled Fast KVs with Pebble. So has anyone here worked with like a sorted string table or level DB before? Cool, okay. I think level DB was, I think SS table was the original research paper, level DB was the first Google project, and then there's been multiple variants afterwards. And I think RocksDB is probably the best known variant these days that's still used in production. The idea here is like, we want to be able to query a 10 billion plus record data set of host names to values. You want to do it really, really quickly. And the values could be like C names, could be IP addresses, names can appear more than once. Anytime we have multiple values with the same name, we need to merge them. And then merging has to be like smart merging. It has to like deduplicate it, put it in the right order, be smart about format, things like that. And we have to be really cheap. We can't spend too much money doing this whole thing. We have to be really fast and do it on a daily basis. And once we have the data, we have to return results like effectively instantly. Otherwise, there's no point in doing it. So how do you return 10 billion results instantly without giving tons of money to Google or Amazon or Microsoft? That's this talk. So the common approaches would be like, put it all in Postgres, stick it all in MySQL, stick it in the big SQLite database. The biggest challenge with those is that the index size gets really, really big on those, especially if you're trying to indexing like wildcards or prefixes. Like you can use trigrams, you can also do the stuff, but at the end of the day, like it gets tough to do. And the biggest challenge for something like Postgres, unless you're creating like a daily partition, dropping the previous, adding the new one is a really expensive operation. If you're actually deleting 10 billion records every day in Postgres, that's almost more expensive than inserting it a lot of times, depending on your schema. So removing records unless you partition in advance by date is really difficult for a lot of RDBMSs. NoSQL is actually not a bad fit for once. Like you can actually like, the only problem is like once you start going down the path, like once your data set gets bigger than memory, I know Mongo says they work now, but I don't trust it. I once had a Mongo database that was, my laptop basically crashed when I was on a plane flight to go to the place to give the talk about it. At a 50 gig Mongo database, I was frantically trying to run the Mongo restore command, and by the time I landed, it restored 300 gigabytes out of my 50 gig file. I was like, this can't be right. And then my disk was full and overwrote all the other artifacts, so there's no way to get it back. And so there's a loop in the BSON structure, so a bit got flipped, and then they kept cycling back in the BSON, dumping it repeatedly. So I've never used Mongo since. So hopefully that's better now, but yeah, just say no to Mongo. There's also like, column restores, like Sandra, things like that. They could probably work. I don't know them well enough to say like if that's a good fit or not. But if you're looking at how to put 10 billion records into one really small server and serve requests instantly, I'd love your feedback on it. My approach was to go look at key value stores. The problem is the cloud-based key value stores, they're charging an arm and a leg for it. Using DynamoDB or BigQuery, like you're going to be paying way too much money to look up a key value. And then there's also the really, really dirty version, which is like create a bunch of files and then use your file system like a key value store, right? That's what a lot of people do too. Like take ZFS pool and just say, the database is my file system, done. So, if you go back and say, well, who else has this problem of having billions of records? You have to do this lookup in this particular format. Well, basically anyone who does DNS. So who does the most DNS? Well, about 5 years ago, was a company called Farsight. Farsight sold passive DNS databases. I think previously Simaru was probably the only provider at that scale. These days, a lot of other people sell that, but effectively they had these like multi-trillion record data sets that they served up. And to be able to serve them up fast, they put them into a sorted string table, which is one level of a level DB. And RocksDB is a multi-level sorted string table database, effectively. The idea is that the sorted string table splits the keys into one bucket and the values into another bucket. And the keys are also compressed, and the keys are really fast to iterate based on range. So if you want to say find everything starting from A, B, C, D, that's super fast. If you want to say like find me everything with a second character Z, you're screwed. You have no way to do that. So as long as you can do a prefix-based scan and a sorted string table, it is incredibly fast. The problem is if you want to do a forward lookup of a domain name, like let's say, www.runs0.com, for example. Well, you don't really want to store it that way. If you store it in that way, you're going to find all the wwws. Like, that doesn't make sense, right? So you got to do the whole like Java package style com.wrap7.ww, then you can find all my com.stars and all my com.wrap7.stars. So when you start getting into key value stores, you have to think really hard about your key syntax. And if you want to be able to look it up the other way, like let's say by IP address instead or by record type, you have to build a totally separate database. You can't just add another index. You have to actually literally build a brand new key value store that does the inverse lookup for what you're trying to do. So generally, the difference between like a sorted string table by itself and a level DB is a sorted string table you only write once. Effectively, it's write only. You can write it once and then, you can write it once and then it's read only afterwards. If you want to change anything in the sorted string table, you have to rewrite the whole table. So what level DBs do is they actually stack up change sets into sub-levels. So if you have a hit against a key, you bring another level below that, it's level 1, then level 2, level 3, and eventually you have this thing called a compaction, which compresses all your levels back to level 0 again. So that allows you to have like read-write database based on sorted string tables, but it's effectively levels of sorted string tables. The challenge with that approach, though, is that the compaction phase is really slow. And if you're trying to write 10 billion records, like you don't want to compact things. That's a bad use of your time, because the compact phase, even with RocksDB, is still single core in most cases. So if you're trying to take 10 million records and you put them in random order into the database, well, as soon as it does a compaction, you're now waiting 50 minutes for it to like chew through and put them all out and right over again. So anyways, Farsight created this library called mtable that was really, really good at doing sorted string tables. It wasn't very good as a level DB. It's just a single level in that sense. So it's unfortunately, after it got acquired by Domain Tools, it's kind of semi-abandoned. The packaging's a pain in the ass. You have to go install like the GitHub version, the Git versions of like libsnappy and libstandardz. You can't use the packaging versions of it. It requires you to really sort your input before you write it, and technically it has a sort function, but it's really slow, single core, doesn't work very well, and then if you're calling it effectively through Go through the Go wrapper, and there's originally a Go wrapper, I rewrote a lot of it, it's up there in mtable Go, but it's a little bit buggy still. Like occasionally it'll get like weird memory corruption and crap like that, which is no fun. So I was like, I used this thing like 10 years ago, it works fine, but it was janky and I didn't want to do it anymore. So I started looking at some other alternatives. So we talked about most of this already. Level exists, you keep writing new entries. So the idea is we really want to pre-sort the database. And because we're going to be tearing this down and rewriting it every single day, like we need a cheap way to write new stuff. So I need to efficiently sort 10 gigs of gzip CSVs in Go. Like, should we use like parallel to the pgzip package instead of like bzip? Should we use lots of channels, Go routines? So I tried a million things. I created like every possible Go routine mechanism you could ever think of to do sorting of strings. And like finally it occurred to me, like, why the hell am I reinventing this wheel that has been beat to death already for 20 years? Like, there's a tool called sort. It's amazing. Like, sort does so much shit that no one knows. Sort can run random commands. Sort can use all your CPU cores. Sort can do like multi-gig memory buffers. It can use a separate SSD for its sorting tables. Like, sort is the coolest utility on the planet you've never looked at the -H output for. And anyway, so I love sort. So sort's really cool. So the idea is that one of the neat things you can do with sort is as a compressed program. And you can tell sort that instead of storing all the raw data directly to disk, to run it through a compressor before it writes it to disk. So the biggest challenge you would have when you're sorting like a 10 gig compressed file is that it decompresses to 100 gigs, right? So you don't want to store 100 gigs of stuff on your disk ever because your disk becomes your bottleneck for I/O. So effectively, you tell sort to actually use PIGZ, which is the parallel gzip tool, to compress it out before it goes to the disk and local disk. And now you're not, even though it's using your CPU a little bit more, it's actually saving you a ton of disk I/O and you're getting rid of the disk bottleneck. So the short version of all this is make your Go a giant bash script. And effectively have a giant exec command, nice sort -u, backsize key, stable, field separator, compress pgzip, parallel, temp directory, buffer size, all that fun stuff. Get it all set up just the right magic way. And then you take the standard input of it and you take the standard output of it and you then hook those up to other Go routines. So now you're actually feeding in data into the pipe from one Go routine. You're taking the data from the pgzip sort pipe after another Go routine, and you can actually use that as a merge pass. So you're effectively getting to outsource all like the horribleness of sorting stuff quickly to the command line, bring it back into Go again, and it works really, really well. So in this case, we create the sort process, we start it, we then hook up the standard in, standard out, we hook those up to our resource file and our roll-up sorted values functions. The roll-up is the one that merges the values, keeps track of it, and then we basically flush it all out and wait for it to go. And this code's about all to be open source, so we can actually talk about it. We stopped using this particular implementation recently, so we're able to switch over a bit. But So there's some functions here like merge helpers, like merge newer versus merge older, finish merger that sorts it all a certain way, does tab separation. This is what, like, anytime you have two keys with the same value, how you actually merge them together. And then you do some stuff down here. One of the things that is kind of weird is we actually set the environment LCLC. Any guesses why you want to do that for this particular type of program? So because we're calling the sort command under the hood, sort will actually look at your LCL variable, and if it's set to something like, you know, NGB or something that's not UTF or UTF-8, for example, your sort output can be entirely different than what you expect because they use your locale to sort it. So if you have like a Chinese local character set, when you do the sort, your sort will not be, you know, lexical in UTF-8 or in English. So setting to LCLC is effectively a byte-wise sort, which is also way faster. So it ends up if you set it to LCL to C instead of LCL equal UTF-8, even on your local command line, I actually recommend you throw this into your .z shell RC and stuff like that, because your sort command will go 10 times faster than it will be with UTF-8, because you're not trying to sort based on UTF-8 bytes anymore. You're sorting based on just byte-wise. So, like everything else I do, I'm really lazy and I spin off a pprof debug server on a random port down to loopback every time, because if something breaks, I want to be able to like diagnose it without having to like delve it or break it there. So it's always cool, like if you're writing a long running program, like this thing will run for 4 or 5 hours sometimes, depending on the size of the data set. You always want to be able to hop in and like dump the Go routines, look at the memory usage, look at heap stuff. So I'll spin off a little debugger. There's a little helper library called pprof that I like, just because it's like debug pprof, but it only binds up loopback. So it keeps you from exposing it to the network by accident. So we get some other stuff like all the normal sort stuff, how much memory, all that kind of fun stuff, do the thing. Anyways, so it's not super exciting. All this really does is sort it all up. And when it's all done with it, it basically creates a PebbleDB. Oh, sorry, I'm jumping ahead a little bit here. So if you're going to try to replace mtable, which is like the C library of the wrapper, with pure Go, there's a bunch of options. So you got BoltDB, which is okay at like sub-million records. Once you get beyond that, it starts to crawl a little bit. You got RocksDB, which is like probably the industry standard, but it's C-Go based. There's a bunch of C in the back end, and it's a pain in the ass to compile it across the platform. So if you're trying to deploy, like if you're building on a Mac ARM and you're shipping to Intel, it's kind of a pain in the ass to get it all going. And I'm lazy and don't like doing that. I really liked Badger for a while, but Badger started to fall apart when I got to about like 300 or 400 gigs of data in a given data set. It really started to crawl. Like it tries to start compacting crap even though we tell it not to. Like, so I like Badger for stuff, but once you get about a couple hundred million records, it starts to fall apart too. Then there's something called Pebble. Pebble is actually like a miniature, only pure Go version of RocksDB, written by the Cockroach DB team, and it's fantastic. It is Go only, it is fast, it doesn't do stupid things. It actually even works on Windows. Like all the things you expect it to do as a library, it does it right. So I really like Pebble. So I managed to port everything that I'd ever written before on BoltDB, RocksDB, Badger, or mtable has all been ported over to Pebble on my personal repos in the last like 3 months, because I really enjoyed using the PebbleDB, and it actually does the right thing, which is nice. So of course the hard part about storing key values is you really have to think about like your key storage mechanism. So you have to write your keys in the exact format you're going to query them. Otherwise, if you can't query your key by a prefix, you can't use the data. So it's kind of like DynamoDB versus Postgres. You have to be really careful about your keys. And of course, you have the pre-sort input. So you don't have to pre-sort your input with Pebble, but if you don't, you're going to force a compaction, and a compaction is going to kick in like a garbage collector every so often. So it'd be like you're humming along 1 million records per second, all of a sudden, boom, everything just stalls out for 5 minutes. Like, what the hell are you doing, Pebble? Poke, poke, poke. Ends up it's waiting for the compaction to go level 1 to level 0 again. So the way you do that is you pre-sort it all with that giant sort command first, and you throw it all in the Pebble afterwards. It never has to compact it, because everything's already magically lessively sorted in the order of the bytes. So it's a neat like shortcut to never trigger compaction of writing to a key value level DB. So we've got this giant Pebble, this directory full of Pebble DBs now. We've taken all these files, generate these Pebble DBs. You take about 10 gig compressed text from about 50 gig compressed Pebbles. And the idea is the next step is we want to turn that into an API server. So we take a query like star.example.com, and we turn that into 2 queries actually. One that's an exact match. So you can find me exactly this key for example.com, and that's it. The next one is a prefix match of .example.com. So we can't just use example.com, otherwise my example.com would trigger, right? It's going to be a string comparison, byte comparison. So you have to create, so you're basically creating multiple queries for the results of one input for the user. And then the next thing you do, one thing that Pebble is really cool with that very few other key value databases do, it gives the ability to set your,
What's the prefix? Is it in a suffix? .example.com is it in a suffix?
Yeah, yes, we're flipping it around. So when it gets, you're right, the query example should have been com.example and com.example dot. It's actually reversed when we do the real search. For clarity, I put it like this, but you're right. When you actually do the real query in the Pebble side, it'll be com.example exact and com.example dot prefix. So you're flipping all the names around to do the reverse kind of package, kind of Java style packaging. But one cool feature about Pebble that nothing else has out there is you can tell to set the minimum key value even before you do your first iteration in seek. So effectively, you're like forcing your seek pointer into the key index file into the beginning block where there's no value below that that'll overmatch the iteration you're about to do, and it saves you a ton of time. Otherwise, you're seeking forward for no good reason. So you can set your minimum key first in Pebble, and then you start doing the iteration, and it's way faster than it would be otherwise. So the idea is you seek the very beginning value, you start matching the iteration, and then the first value that comes back out that is greater than your prefix, you just do bytewise, less full, or whatever you want to do. You say, okay, I've gone off the end of it, that's no longer a valid value, kick it back. And then merge all your results, do your thing. And the cool thing about this is if you have a new daily data set, you just copy the same directory, and then as long as your server is smart enough to walk the file system each time and handles errors when the files are like halfway written and generally bogus, you can just basically throw things in a directory and magically takes new data sets, takes them back out again. So really neat way to handle graceful API stuff. So short version, we got this big ass pile of CSV files. We're gonna figure out a key format and merge values, a value merging strategy. We're going to use PigZ as a compressor. We're going to use sort with parallel sorting on it. We're writing a little merge function and Go, hook it all together with all the pipes, flush it all with Pebble. And the other kicker here is that we want to run this in GitHub Actions. But GitHub Actions, they max out at 32 cores. And these are 32 crappy cores. Like, if you have a 32 core box at your house, like just your gaming PC, for example, even like a 12 core gaming PC will have so much better performance than the 32 core GitHub Action runners. Like, just literally like 3 or 4 times the time spent. Like, your crappy old laptop from 3 years ago is better than a GitHub runner. So just keep that in mind in terms of price performance. They just added some new runner types a little bit less bad, but the default GitHub Action runners are intentionally hobbled. I think every server that's ever been like kicked out of another data center someplace, they put it in a bucket someplace, that becomes your GitHub Action runners. Yeah. They just take all the old lame ducks that are out there, kind of, that is the upstate farm in New York where the servers effectively use GitHub. Anyway, so those suck. So if you run on your own GitHub Action runner, you get a lot more performance because you can have SSDs, things like that. You can also do caching a lot better than the existing caching limits in GitHub. And then you serve a request, you convert user query to Pebble operations, set the minimum key, iterate, break, etc. But the cool thing is we're taking these like multiple directories at 50 gigs at a time. In some cases I've had like 300, 400 gigs of Pebble files on a single server with 16 gigs of RAM, and it could serve millions of requests per second and at very, very, very low latencies. So it was an incredibly fast way to do it, and so much cheaper than putting in DynamoDB or anything else, right? So quick example, this is just an example earlier today, time curl, DNSDB, API host, queue. We said, give me everything in .gov, no matter what, all the govs, all everywhere. And 250 milliseconds basically to bring back all the govs in one shot. And this is searching about 300 gigs of data instantly on a 16 gig RAM server. So super, super cheap. This code will be open source fairly soon. I gotta clean it up. Basically, we stopped using this particular mechanism for it, so we're gonna open source file and donate it to the WhoisXML folks, so that they've got other customers using their DNSDB product and can use our stuff for it. So here's the generator for it. It's all not particularly exciting. It just does some cleanup with IPs, parses IP records, buffers things a little bit. Oh, one gotcha with Go that you probably have never run into. If you're writing to a standard in or writing to a standard in pipe of a program in Go, the buffer size matters a huge amount. So let's say you're writing things in like 1 line at a time into the input of like the cat command. You'll get a maximum performance of literally writing to cat of like 1,000 lines per second. You're like, what the hell is going on? Why is it so slow to write input to some other program already through a Unix command line? Ends up the buffer size is like critically important. So we actually use a 1 gigabyte buffer size to write to the standard input of the program. Otherwise, we get blocked on the maximum writes per second we can to the pipe itself of the command and Go. It's just a weird gotcha that I never into before like this. So that's not part of it. The other part is the server. So we've got a little server. It basically takes in user commands. You can give it an API token to lock things down if you like. We do some authorizations, some headers, all the normal fun Go stuff. We get a little snap back in, load the databases. He scans all the Pebble DBs, loads them up, finds everything called .pebble, doesn't care if it breaks, and then when we do a search, we take the values, we search all the databases, all the targets. Where's the set minimum somewhere around here? Emitter, CGE is valid. Yeah, once you get past if it no longer has a prefix anymore, we know it's gone outside the results, and then basically we're done. So that's it. It's just a super dumb little Go server, but this saved us like so much money. Otherwise, we'd be running like, we're just piling money into some cloud provider for key value store that we didn't even pay about 24. So yeah, just keep in mind, you can serve hundreds of gigs of stuff of key value stores incredibly cheaply with Pebble on a really low server, as long as you cook your data the right way going into it. That's my talk. Thank you. Any questions?
Remind me again, like, how long is the process of getting all that data sorted and then done somewhere?
Good
How
question.
hours?
It depends on the data set. So when it's about 10 or 12 gigs total, it's about maybe 2 hours total.
2 hours?
It's about an hour and a half to do the cook and then another to just the processing and get it online.
And when you say like self-hosted runners, you're talking about like an actual VM, not a container, right? Because
Yeah, this is like
a
a
very
EC2 or DO or something like that. Nothing
Okay,
really
cool.
exciting. Like really boring Ubuntu box with 16 gigs of RAM.
Cool.
Cool. Awesome. Thank you very much. I think that's it for talks tonight. We've got the room for another 20 minutes, then we'll start cleaning up. So please eat all the pizza and all the beer you can. Otherwise, we have to carry it home.
Yeah, take whatever you want home as well, food-wise. So before we wrap up, like I was saying earlier, if you've got ideas for talks, you've never given a talk before at a user group, but you've got ideas for something that might be interesting, please let us know. Most of the time, we're open to having longer talks. Since this was the first time back, we wanted to have some more rapid-fire ones. But you know, if you've got, you know, we'll take of any length. If you got like a 30-minute talk, we'll do that. You got an hour-long talk, we'll do that. If you have a 3-hour-long talk, we will not be doing that here. Good for you. That's amazing. Maybe we'll split it into chunks and do it over a couple of months or something. But no, not for one night here. But yeah, if you've got you know, ideas, let us know. We've got a lot of people here who've got experience dealing with that kind of stuff. I know for sure. So I was actually scheduled to give the talk for April of 2020, but you see, we didn't have that one.
Why?
And so I feel like I probably owe y'all the talk that I was going to give back then. So that means that I actually have to go and do it again now. So it was going to be on.
Shouldn't tell us, because then when you speak, we say, man, you have 4 years.
Better be the no, I'm just giving you a heads up. There is a suite of tools called Expect that is originally created for a programming language called TCL. And so it's really common for doing like what we would call black box testing. So on the network, you have some weird devices out there. You have no idea what they're doing, or you just like really, really far removed. Like the only way you talk to it is over the network. You're not on the same computer as it. And so you want to be able to test that something, you send these bytes, it sends these bytes. You send these bytes, it waits this long, and then it sends something back to you. And that's kind of the level that most of that kind of stuff happens. In fact, you can use that tool for all kinds of things. That's just usually what, that's the most common use case for that particular tool. The TCL language was a brilliant idea at the time, and it is very, very strange by modern standards. It would be, if you've never used it, it would be very disorienting if you tried to use it. And so that is why many other languages have come up with equivalent notions. There's one in Ruby, there's one in Python. But frankly, Go lends itself to that kind of thing better. And so there are several people who have connected those dots, and so there's quite a few implementations of Expect in Go. And so my talk is going to be on that. We've also got people who are interested in giving talks on WebAssembly, creating WebAssembly binaries from Go code. That's a common area of interest for some folks, and so there's that. Again, like I said, if you've got ideas for other things that would be interesting, please come and let one of us know after the fact, not right now, but like, you know, and we would be happy to assist however we can and get you on the calendar. Other than that, as we said, we assumed that second Wednesday would make sense because when we were thinking back, that seemed like when we were doing the most of these meetings before the pandemic, when we were at 5 and 5. If that day doesn't work as well for folks, let us know. You know, again, either in the Slack or just contact us directly. But tentatively, I think we're assuming that's going to work the best.
Here, so.
Yeah, well, I mean, it was pointed out.
The parking is free on Mondays and Tuesdays, so like, if people want to park in the street on Mondays or Tuesdays are better than Wednesdays.
This is fair, yeah. So that's the kind of thing worth considering. So definitely reach out if you've got thoughts on that. We weren't sure how many people to expect. It seems like we had a pretty good turnout. If we consistently get a turnout like this, we'll probably fit in this room. If we grow a little bit, we may need to ask our kind host at Capital Factory if they would be willing to let us use the larger room. But so long as we're at this size, I think this probably works. We'll just make sure to get the chairs ahead of time instead of last minute. And we'll have our stuff a little bit better together next time. Now we've got an HDMI cable for this group. We've got that all settled now. But yeah, as we said, main places to reach out. Of course, the meetup.com app. It's got ways to communicate on there. We have the ability now to create new events. We don't yet have control over the top level page, so if you see something in there talking about it's going to meet at 2005 on a different day or whatever, don't look at that, look at the event pages. I think we're trying to get that fixed, but that's where we're at the moment. And of course, the Slack, the Pound ATX in the Gopher Slack is probably the best place to get in contact with all of us. So, yeah, any questions or thoughts? Yeah. Oh, yeah.
I guess main question to group. So we kind of just default to doing talks this time. Like, what other type of things would you like to see that in a meetup, right? This isn't just like listening to Flower. This is a do stuff that helps you with your career understanding of Go, or share stuff. Like, do you want to do like pair programming? Do you like doing projects? Would a hackathon be fun? Like, what other stuff would be more valuable than throwing together talks?
One thing we did was, they didn't have a speaker lined up, and one thing we'd done back in Perl Modders days that I always thought was really fun is just like bring your difficult problem code and just have people help you fix it. And I always learned stuff that I didn't expect to learn. So not often, but every once in a while.
That was always
Chad, like you have Chad, you can do that for you now.
Well, yeah, we would be a lot better at it. So. Yeah. There is another thing that often came up. I know. So when is GopherCon? Is that it's coming up in a couple?
July 7th. Chicago. So it'll be Chicago this year, and it'll be the last year in Chicago because of COVID, they got like locked in Chicago because they didn't meet like contract numbers and stuff.
Yeah.
It'll be the 10-year GopherCon.
Okay.
So it should be pretty big.
Cool.
That's up to Escape Florida, right?
Right.
Well, so it used to be in San Diego.
Yes.
And then it was in Denver as well. So.
And I can get back and forth to San Diego.
Yeah. Cool. Yeah, that first the one time I went to GopherCon, I did not realize how close that was to Comic-Con. So I went the weekend before and was like, man, I know California is expensive. I can't believe how expensive it is. Like, it is like more expensive than South by Southwest in Austin for like the weekend. Like, what is happening? And then it was like, oh, it was literally during Comic-Con, and I did not.
I think that was 2019.
Yeah,
wasn't it?
yeah, 2019.
Yeah, that was my first GopherCon.
Yeah. Nice. Yeah. It was. Yeah, I went there like a couple days ahead of time, and I'm like, wow. This is not what I was expecting at the airport or walking around, and I was like, okay, well, I guess I'm gonna go and meander around Comic-Con and see what was going on. But GopherCon was great though.
We did a conference in DC that was like a military open source or open source in the military conference, but it lined up identically like overlapped by one night with FurCon.
Oh, there you go.
All these folks like the full general regalia, like all the stuff, the stars and stripes. Then you had the folks running around in fursuits.
Yeah, there you go.
Perfect.
All right, that's an interesting mix. Yeah.
I was going to touch on another format because I see this also as being a great opportunity. Like if you have an upcoming conference, like practice session, present to everyone. But Cassie and I are doing a workshop later this year, and it'll be a workshop on Dapper. So like we're gonna put together some code and habits where you can like fill it in using the Dapper APIs. So I think that could be fun. Like I want to like go through. It'd be like hands-on coding, like in a workshop. So we can do stuff like that. Too.
Yeah, for sure. Definitely one of the things that was that I just blanked on the GopherCon thing as well is like afterwards we would usually have like a summary and like go through what talks you saw that were interesting and kind of go through them. So that's a common one as well. But the workshop thing sounds great. we should totally do that. Another one that we have done before, I don't know if we did it at Fathom 5, but we definitely did it here at Capital Factory before, was a bug squash-a-thon. And so we found a couple of Go projects that had a lot of known bugs that just didn't have any fixes. And so just went through and tried to see if we could fix, I think one time we did Kubernetes, and at least at the time, Kubernetes was not difficult to find bugs, and it was also, but fortunately it was not difficult to fix them either, and so that was cool.
We should plan to do something like that in October, because
Okay.
in the open source community there's a thing called Hacktoberfest.
Oh, Hacktoberfest, okay,
Yeah,
nice.
we should like
They use t-shirts for that, right?
Yeah.
Do they still do that?
I mean, I don't know if
I
it's
think they
still
saw, I
there.
had that back.
But we should plan on doing something like that.
Yeah, that sounds great. I know, I'm not actually sure where the this logo was made for the Austin Go group before, and I don't remember where it comes from originally. But
I think they specifically made it for us.
Yeah, it's for us because it's supposed to look like Willie Nelson. So, but at one point we actually had someone had made a pile of stickers. I don't know where those are or if there's any left. I mean, I have a few for myself, but maybe we can get another set of them created and give them out for speakers or something. So, other thoughts? Yeah.
Like, I don't know how it's going to be, but maybe talk about the sustainability of meetup, of sponsorship. I remember, I don't know, years ago when the meetup was here, but like my previous job to sponsor the night or whatever, like, I don't know how to
buy
pay
pizzas
for
and
those
stuff.
things.
Yeah.
But
Yeah,
that'd be something to keep in mind.
Yeah, certainly. If you know people who are wanting to throw down some cash, possibly to let everyone know that you're hiring or something like that, then by all means, let us know, and we'd be happy to let that happen. But in fairness, like I mentioned, it definitely worked. At my employer, WP Engine, back then, we sponsored it multiple times, and we hired quite a few people out of this group at WP Engine. And so some of our really great developers that we've got came from this group. And so yeah, it's definitely a thing that has happened before. And so if there are people who are interested in sponsoring, by all means, let us know. And it's a win-win, because there's also going to be people here who, as we mentioned earlier, might get visited by the layoff ferry, and so coming here to this group is a good place to go get that fixed. So
we can probably kick in near the end of the year. We just filled 3 reps, so we got a little time to ramp people up, and hopefully we can do a round on the sponsor later this year for the 1.0 site.
Oh, nice. Okay, cool. Awesome. Yeah.
I guess another thing to throw out there is, like, you talked about the last group. Like, what other meetups do y'all go to, and like what kind of overlap is there?
Yeah.
Today there's a Python meetup.
Yeah, there's Python.
Oh, ooh. I was in the Ruby house for like 10 years, so
Yeah.
So Ruby meetup was yesterday.
Oh, okay, cool.
I'm a regular at the 2600, and sometimes I go to another group that meets on the north side that is behind closed doors, and it's like Fight Club.
Yeah, it's AHA. So that's, so that's a group started about 16 years ago. So the idea is you show up, you have to talk, but we do like 15 talks every time, and it's just one big drunken blur for 3 hours. You don't have to drink, but it helps.
But you're not allowed to talk about.
Yeah, you can't talk about the things you see there or do there, but you can definitely talk there. So we use it as like you mentioned, like If you'd love to talk to Black Hat, you do your preview of your Black Hat talk there first, and they have a bunch of drunks yell at you until you're wrong, and then you can so it's a good easing/feedback loop, I guess. But,
Yeah.
But AHA's a lot of fun. 2600. There's ATX 512, which is now down at
DC 512. Yeah. They meet down on kind of towards the airport. There's a brewery, Independence Brewery down there, and they meet on the first Wednesday. AHA is last Thursday, and 2600, wherever you are, is the first Friday of the month. At whatever location's posted in the back of the magazine.
And it's hackers, but hackers who also write code, and then everyone else meets.
Yeah.
We have lots of reviews who show up. We have lawyers, police officers, you name it. So general rules, like we don't care if you're a cop, you still have to talk. Right?
Yeah.
It's fine. But generally, your talk could be like, hey, my name is so-and-so, I do this stuff, or it could be, here's a cool code thing I'm working on, or it could be, I worked in this book, or it could be anything else too. It's generally like, somebody showed up talking about the best fishing holes in Austin. He's a consultant, and he kept getting stuck waiting for someone to let him into a building, so they started fishing in like the drainage ditches by whatever office he's at. Like, I caught a big bass at Fail Lake across from Google building. Great.
So the WebAssembly group is every Tuesday, which is wild, at the Meteor. But it's more of a social thing, kind of like 2600. 2600 doesn't, in most places, doesn't have talks. It's designed to be conspicuously open, with the idea that there's a lot of people who are really socially awkward, that is the first like social group that they ever go to, and so that comes with some good and some bad, but DC 512 has like the Chatham House rules where you can talk about what you saw, you just can't say who said what, and then AHA of course is more like Fight Club rules. But then the WebAssembly thing is on Tuesdays, and that is kind of like the equivalent of the 2600. It's just meet up, hang out, talk about whatever. Let's see. There are algorithms groups that meet up at the domain on Saturdays, I believe. So it's for folks who are what?
Really.
Well, it's more of like just practice. It's like dedicated time to practice. Oh. Yeah, that's what it is. I mean, I wouldn't. That's the thing. There's a variety of different kinds of things in groups. Here at Capital Factory, like there's like a group of some kind almost every single night of the month. If you get to a month that has 5, Wednesdays, 5 Thursdays or something, then maybe the last one will get a little bit sparse. But most of the time, there are like 4 or 5 different groups that are meeting here at Capital Factory every single day. And so, if you're ever curious, definitely look at the calendars and stuff they've got. There's always something interesting going on here.
But there's nothing ever on like Friday, Saturday, or Sunday.
No, yeah. It's 2600 is like the only Friday thing, I was we had a formal methods group before the pandemic, trying to bring it back. I will obviously let people know if that comes into existence. That could potentially be of interest to the people in this group, because there is an effort to try to formalize Go, which is interesting because right now it's just C and a few functional languages. Like they're working on Rust, but they think that's going to take a long time. But some things about the way that Go was designed, it won't be as useful as if Rust gets formalized, but it will probably take a lot less time to do it. And so you could suddenly see a giant pile of really interesting, weird tools that do magic things, and that would come out of that kind of work. So that'll be interesting if that happens. Other groups, obviously there's going to be a bunch of Linux user groups and stuff. So I mean that's, as you expand out, I've not been to any of them in a long time, but.
I don't think there's actually any right now.
Here in
Linux user group, I think it's
the last.
It hasn't been alive for a while.
The one here in Capital Factory or in Austin in general? Because I thought the one in Capital Factory was long gone, but
there's one that meets on the 3rd.
On the 3rd.
I don't know which Thursday.
Okay.
Thursday.
On a Thursday. Okay.
All right.
There's one
I haven't seen one like in a while.
Yeah.
I think there used to be one, but I don't think it's been around for a while.
Yeah, there's one that used to meet at the Region 13 educational building or whatever, and they went all online. I think there's still
there was We used to have the C user group as well back pre-pandemic. Yeah, Rackspace for a while, but or BB Rovers also.
Oh yeah.
Yeah.
The C++. I don't know
Yeah.
if
Well,
it's
yeah, it was
same
the same.
one.
Yeah, yeah. It was the same group.
Yeah.
So.
Yeah, I still get stuff from them online every once in a while about, oh, there's some conference or something that we're gonna go do something at.
Yeah, but yeah, if other people have suggestions or whatever, please reach out. You know, trying to build the community back up. You know, we are definitely grateful to the folks at Bat and Phi for you know, carrying the torch for such a long time. You know, and so. But glad to be back here at Capital Factory as well. They've been good to us for years, and so happy to be back here. So, yeah. Anything else?
So thank you all very much for coming out. It'll be great to see everyone. We're very glad to kick off the thing. So.
Yeah. And as we said, pizza and beers, please go after it. We're gonna have to. So the way the rules work, we are here from 7 until 8:30 is when the recordings and stuff are going to be going. We officially open the doors at 6:30 for pizza and beers and stuff and socializing. And like, no joke, we got to be out of here by 9, and that's the rule. So we can chat. We can go down to 6th Street afterwards or whatever if you want. We got options here, but we can't be in here. You know, as they say, like you don't have to go home, but you can't stay here at 9. So yeah. Yeah, there is a bar here. I know the EFF group. That's another group. They meet here at Capital Factory as well. A lot of times afterwards, they'll end up going to this bar. I know there's a bunch of people who like going to the bar over there at the Driscoll. That's a popular one. It's like not the cheapest bar, but it's the kind of thing, if you're going to a place where you're going to get one drink, it's going to be a good one over there. And so there's something to be said for that.
Is Small Victories still open? It should be like a lockout.
Yeah, Small Victories, it's like, yeah, it's right over there.
They've got like everything from the giant punch bowl runs to like everything else in between. Fantastic bar staff.
Yeah. Floppy disk repair company. After the thing's done, I'll let you know how we got our way into there. But that's another interesting one. Yeah. So if folks are ever interested in any of that, just let us know. Yeah. Thanks for coming out.
Thank you.
All right.
Probably I have not interviewed a podcast.
Also, pass the front line so you get it.
So remember from the Founding 5 Go meetups, how long has it been since they had one?
So they had one in December that I couldn't make, so I had all that shit going on, and that was it. They said, oh yeah, we're going to have a real big one, we're going to have all kinds of great food, and it's going to be amazing, and and then they just...
I guess a few months before that I went to and really showed up. Eric Taylor was there.
Well, I think, yeah, there was one where I didn't like going because I think they didn't like go back to my car. This is like 3 or 4. Eric had a lot on his plate. He didn't have the tuits to... Yeah, well, and he ended up speaking at like every other meeting, and it was just like... I actually kind of like the lightning talk format, but just getting enough people to talk is like... I mean, I need to get back... I haven't written Go in months, so I need to get back into some of my little toys and talk about them.
I guess I'll send you guys an email or something.
Go for it.
you guys do the Gopher Slack?
Yep.
Yeah.
How do we
If,
get
by the Gopher
Slack?
I think it is, or at least back in the day, you could go, I think it was gobridge.com, and they just have a link, and there's like, you're invited to the Gopher Slack, you click it, it's like automatic, here you go, just put this and you're in.
I got into dancing like.
But that was when they first started it, and I signed up, so I don't know.
Sweet is one of those situations where like someone that's in Slack, that's why people like can invite me, maybe.
They reached out.
I had a start.
I don't think it's like that. Or at least it wasn't. No, it was never full. It's just like, we have to have some kind of invite mechanism, so here, go here, you know, like.
It's supposed to be GoBridge.com.
I thought so.
Once they see it's recorded, we actually meet and everyone's like that. They're like, oh, not as here, okay.
Yeah, if you go to go.dev.
I don't think they actually they're probably just making the change line. Timeout. But if you send an email or whatever, I get in touch with that guy who sponsors, they work.
It's Gopher. Oh, okay. Got it.
Yeah, I saw that same message.
And for a while, we even were on IRC. It was like me and Trevor was in there. And nobody else was on IRC anymore, so we're like, okay, fine.
Yeah, excitement comes after lots of.
It was kind of like Slack was becoming a thing and IRC just fell off. I still prefer IRC. I mean, it's still a thing, it's just that getting enough people from a local meetup to be on IRC all the time idling is difficult. So, I just prefer the spontaneity and being able to write. I had a Go IRC bot that could like print an ASCII weather forecast, complete with like graphs and stuff and all kinds of stupid stuff. So that was a lot of fun. Maybe that's I should revive that.
I guess we'll do the meetup.
So you got one slice. So we didn't consolidate or we're gonna use it. If you want to fill it up with more, we've got 3 more slices there all.
Okay, I'm
It's been a bit since I actually used IRC because all the channels I used to use are completely dead now.
Well, were you on Freenode?
Yeah.
And it all went to Libre.
Exactly.
Well, thank you for.
I just didn't go over.
Well,
you have to. There's a certain amount of coordination, you know, like with Slack and Discord, it's just like join the channel, automatic migration, like everything just works.
I don't drink beer.
But I think it's
I don't drink beer either.
You're here. There we go.
I wish somebody would make a good federated, like actually federated chat thing.
So were you like free at the time? Or
I don't know if there's.
There used to be one that they were like.
How did you have the time?
The name is escaping me. It was like this XML based.
Yeah.
You have Google Talk, could talk to your random server that you were playing with Jeopardy or whatever. And then everybody just kind of made it more and more difficult to talk to everybody, and it just kind of went to crap. So it's like email is like the only thing left. It's like anybody can run one, everybody can talk to everybody within reason.
Right.
One drinks before you go?
I'm good. Thank you.
Stop here. At least the kids will drink it.
That's the spirit.
No, like I said, like the 21-year-old has a party. Like all the shitty beer is gone out.
Yeah.
I just put it all in a bucket. Like, it got so bad they started drinking with the non-alcoholic beer. Then they drank like my other fake alcohol. I'm like, wow, you guys are going through it hard.
They're going through it fast.
Yeah.